Okay, like I said, we're going to do 7.4, our introduction to matrices, in two parts. All right, we're going to kind of get the vocabulary and the workings of matrices out of the way, and then we're going to use solving. Move into solving, but we'll do it tomorrow fully. How many of you have seen matrices before? Okay. It's just another way to represent and solve equations. It's nothing super tricky or anything like that. You're going to look at things the exact same way. There's no new math or anything like that. It's just a different way to represent equations. It's a rectangular array of real numbers, right? So there's nothing imaginary. You're not going to have any eyes or anything like that. But the way that a matrix is set up, if you look in yellow, it says m and n are positive integers, or it looks like m times n, but it's red, m by. You're going to talk about the dimensions of a matrix, a 3 by 3, a 4 by 2, something like that. Kind of like you would, like a 2 by 4, similar to that. The way that you read a matrix, okay, think about an xy, right? I have a coordinate plane, right? Everything comes back to our xy. If I'm starting here at the origin, which way do I move first? Left and right or up and down? Left and right, and then you move where? Up and down. That's the way that you name or you read a matrix. You read a matrix row by column. C-O-L-U-M-N. It's left and right by up and down. All right, if you get that confused, you're going to get all of these wrong. So remember, we look left and right, then we look up and down. Do you get it? Yeah. Okay. So on a question as simple as this, guys, this is literally as easy as it is. If it says to determine the dimensions of a matrix, we go left and right by up and down. So I'm going to draw a line through it. How many rows do I have there? 1. By how many up and downs do I have? 1. This is a 1 by 1. That's it. Left to right by up and down. So here, left to right, how many rows do I have? 1. And then how many columns do I have? 1, 2, 3, 4. So this is a 1 by what? A 1 by 4. That's it. So how many rows here? 2 by how many columns here? 2. That's a 2 by 2. Mm-hmm. All right, let's look at D. Left to right. How many rows do I have? 1, 2, 3, right? This is a 3 by what? A 3 by what? 2. There you go. Left to right and up and down. Look at E. How many rows? 1, 2, 3. So I have 3 rows by how many ups and downs? 1. This is a 3 by 1. So when they ask you for the dimensions of a matrix, it's how many rows do you have left and right by how many columns up and down. Does that make sense? You go left to right, then up and down. Everybody good? Okay, let's look at the next piece. All right. It says a matrix derived a system of linear equations, blah, 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 blah. Okay, we're going to talk about 3 different kind of matrices. An augmented matrix, a coefficient matrix, and a constant matrix. Does everyone see what I'm about to highlight here? The system of equations. Yep. Everybody see the system of equations. How many different variables do you have? 3. I have x, y, and z, right? Now compare that system of equations to the augmented matrix. What do you guys notice? Say it again. It is. The augmented matrix is just your system of linear equations. All it is just the coefficients. Notice you have 3 columns, right? X, a Y, and a Z on the left-hand side of those little dots. And on the right-hand side, you have another column. It's got the answers. What is the coefficient of all of the x's? Well, in the first equation, it's 1. The second equation, it's -1. Third equation, it's 2, correct? Look at the coefficients of y. It's -4 in the first equation, 3 in the second equation, and then is there a z in the third equation? No, that's where that 0 comes from. And then you have your coefficients of z's, and then you have your answers. So when they ask you for the augmented matrix of the system of linear equations, all that is, guys, is, hey, what are all the coefficients of all the variables and the answers? Does that make sense? Now, There are two other kinds of matrices that you have. You have the coefficient matrix, which is exactly what it sounds like. It's just the coefficients of the variables. It does not include the answers. And then you have the constant matrix, which is only the what? The answers only. You see that? All right, systems of equations, linear systems of equations, and matrices go hand in hand. This is just another way to solve equations, another way to represent equations. So in a question like this, you'll have these on WebAssign. You can get most of your WebAssign done tonight before you leave probably. It says write the augmented matrix. Well, first of all, before you just go, okay, there's two variables and then answers. How many different variables are there? There's 3 different variables. Good. So remember, you need to have a column for x, a column for y, a column for z. You don't have to write the x, y, and z at the top. I'm trying to show you guys this. So in the first equation, what is the coefficient of x? 1. In the second equation, what is the coefficient of x? 0, because there isn't one. Good. And then in the third, what is it? 1. Okay, great. So now let's look at y's. In the first equation, what's the coefficient of y? 3. What about in the second one? -1. Good. And then what about the third one? 0, right? There's no y. And then what about z's? First equation, is there a z? 0, then what? 4, then what? -5, right? Now, you can write those 2 little dots if you want. A lot of times, I just go like that, I write a line. Doesn't matter. You could do the little dots if you want. But now at the end, we put our answers. So what are my answers? 9, -2, and 0. That is the augmented matrix. It's the coefficients along with the answers. If I wanted just the coefficients, it would be just the XYZ part. If I wanted just the constant matrix, it's just the answers. So what are the dimensions of this matrix? Left to right by up and down. How many rows are there? There's 3 rows by how many columns up and down? 4. There you go. This is a 3 by 4. So if you guys have questions like this on WebAssign, I mean, that's the only work that you can show me. Right? Just by writing it. I mean, there's no math computation behind that. So there's your augmented matrix, and there is the dimensions of the matrix. Questions? No? Okay. Moving along. Okay. This is what we're going to get to tomorrow. All right. We're going to do something today called elementary row operations. You're going to do operations to different rows. But what we're trying to do, and I'll explain this a little bit in a second, and then we'll do them tomorrow, is you're going to try and get this pattern to occur in your matrix. And what you're doing, remember, this is your X column, this is your Y, and this is your Z, and these are the answers, right? Once you get, it's kind of like a Sudoku, however you say that, puzzle. But once you get this pattern to look like this in your matrix, you can then write your equations and use back substitution to solve. And I'll show you what I mean in a second. But on WebAssign, they're going to ask you some questions, and we're going to have to do this tomorrow to answer. But just look at what we're doing here. It says interchange the first and second row. All right, so here's my original matrix. What does it mean to interchange? To switch, all right? So if I'm going to interchange, my new matrix looks like what? If I interchange the first and second rows, what does my new matrix look like? Okay, -1, 2, 0, 3, then what? 0, 1, 3, 4, then what? 2, -3, 4, 1. Good, all right, good. You interchange the first 2 rows. All right, what about this? What does B tell me to do? What's B say? Multiply the first row of the original matrix by 1/2. Well, multiplying by 1/2 is the same as what? Dividing by 2. Okay. Did they tell me to do anything else to any other rows? No. So row 2 and row 3 are going to stay the same. I'm just going to rewrite them. I have 1, 3, -3, 0. 5, -2, 1, 2. The only thing that's changing is that first row. So if I multiply everything here by 1/2, I'm dividing by 2. So I have 1, -2, 3, and -1. Correct? You guys with me? All right. This last one's a little trickier. It says add negative 2 times the first row to the third row. So I'm going to do something to the first row and to the third row. But what does this say? Okay, multiply, good. We're going to multiply the first row by what? Negative 2. And then what am I doing? I'm adding it to the third row. So literally, watch, this is what we're doing. We're taking negative 2 times row 1, and I'm adding it to row 3, correct? You guys agree with me with what that says? All right, so if I take negative 2, what's the only row that's going to change in my final matrix here? The last one, yeah. The first one's going to stay the same. The second one's going to stay the same. The third row is what's going to change. So I'm going to multiply negative 2 all in here. So I have negative 2. I have negative 4. I have positive 8. And I have negative 6, right? And then I'm going to add it to the third row. So 2, 1, 5, and negative 2. That's going to give me my new answer here. So what's negative 2 and positive 2? 0. What's negative 4 and 1? Negative 3. What's 8 and 5? 13. And what's negative 6 and negative 2? Negative 8. Now, on WebAssign, they're going to tell you different things to do. You guys are not going to have to do that in solving. You're going to have to figure it out on your own. And you'll see, I promise you, it's not the easiest thing in the world at the beginning, but it will get easier as we work on it. This next slide shows you on the left-hand side, you have your linear system of equations, right? This is what we had last week. And you're doing all the stuff. You're adding and subtracting and you're doing this and all that to get down to what? To get down to our 3 equations where we can use back substitution, right? So the way that you represent the left-hand side and the right-hand side are the exact same things. Do you see here how it says add the first equation to the second? So row 1 plus row 2. Add negative 2. That's what we did here. Then you're going to divide. What you're planning on doing, and we're going to do this tomorrow, we're going to work through this just like this side. We're not using words, not using letters and stuff like that. We're going to just use numbers, and we're going to add and subtract and multiply and all that good stuff. But you want to try to get your matrix to be like this. Do you see how the 1s are right here on the diagonal, and then there's 0s underneath? You want to get your matrix to do that. We're going to add rows together. We're going to multiply, and we're going to subtract and all that good stuff. But when you do this, if you notice, there's no variables there. But you could write this as a system of equations. This is my x. Whoops. This is my x. This is my y. This is my z. And what are these? The answers. Okay, so if you were going to write this system of equations, what does the first equation say? X, what? Minus 2y plus 3z equals 9. Then what does the second equation say? Y plus 4z equals 7. What does the last one say? Z equals 2. Now, if I gave you this and I said to you, what is the ordered triple? How would you figure that out? You'd use back substitution. You know that z is 2. So now I'm going to take this, I'm going to plug it in here. So y plus, God bless you, 4 times 2 equals 7. Y plus 8 equals 7. What's y equal? Negative 1, okay. And then I'm going to take those two. So I have x minus 2 times negative 1 plus 3 times 2 equals 9. So x plus 3 plus 6 equals, that's not 3. Good job, Jeremy. Negative 2 and negative 1, right? Plus 2 plus 6 equals 9. So x plus 8 equals 9. What does x equal? What's x equal? Positive 1. So there's your order triple. So what we're going to do, starting tomorrow, we're going to have a system of equations just like this. We're going to write out the matrix like this. And we are going to figure out a way to get the whole diagonal right here to be ones and zeros underneath. So if you notice, just by looking at this, what could you do? I know it already tells you, but just look. What could you do with row 1 and row 2 to get this first number right here to be a 0? What would you have to do with row 1 and row 2? Add them, right? If you added those two together, this becomes a 0. What could you do with this row and this row? Actually, what could you do with the first row and this row to somehow combine them and get that 2 to become a 0? Perfect. Multiply the top one by -2 and then do what to those two? You're adding them. Guys, think about that. That's exactly what we did the other day. Didn't we take the first equation and the third equation and eliminate the x's? That's exactly what you're doing. You're just doing it without the variables. That's all we're doing. Yes, you can go back and check using our Gaussian, getting the 3, the 2, the 1, and then back substitution. You guys can check that way, but on a quiz or a test, if it says to solve using elementary row operations, this is how you have to do it. So we're going to practice. That's all we're going to do tomorrow is practice those kinds of problems. It can be a little cumbersome at first, but you guys will be okay. All right, does anybody have any questions? All right, we will finish tomorrow. We're going to start with a problem like this, and we're going to write out, our augmented matrix, and we're going to get our nice little pattern of 1s on the diagonals and 0s underneath, and then you guys can write your equations and use back substitution. Sound good? Okay, thank you.